Hey everyone, we're going to find the local maximum and minimum value using two different methods, the first and second derivative test. So let's see what happens. For the first set, we're going to do the first derivative test. So that's the first method. And we're going to take the first derivative, f prime of x, and we get 6x minus 6x squared. We set that to 0, so let's factor out the 6x, which is 1 minus x. So your critical values are 0, if you set this to 0, x equals 0, and x equals 1. So from the first derivative test, what we do is just look at this little sign diagram. We're going from 0 to 1, and we're looking at this. So let's plug in a value that's less than, less than 0. So let's plug in negative 1. So you plug in negative 1 here, you're going to get negative. If I plug negative 1 in this piece, I get positive. So negative times a positive is going to be negative. Now let's plug in, let's say 1/2, because 1/2 is in between 0 and 1. So when I plug in 1/2, I get positive here. If I plug in 1/2 in this factor, I get also a positive. So a positive times a positive is a positive. Now let's plug in, say, 2. So if I plug in 2 here and 2 here, I'm going to get a positive and a negative. A positive times a negative is a negative. So what we have is we have decreasing to increasing at 0. That's going to be a local minimum. So f prime of x is positive, and when you're doing the first derivative test, you're looking at this second part. Okay, so the gradient is positive. So that's going to be at f of 0, which equals 1. It's increasing on 0, 1. This interval here is 0, 1. All right. Now, from 1, we're looking at our critical values 1. At 1, what's happening? It's increasing. Let's do red. Increasing to decreasing. So that's going to be a local max. So f prime of x is decreasing, and that's what we're looking at. The gradient here is decreasing. So we search for f prime of 1, and if you plug in 1 back into your original equation, you get 2. So this one's going to be a local minimum. It's evidenced by this. And this is local maximum. So this one you have to be a little careful about your signs. If it's positive here, that's a local minimum. If it's negative, it's a local maximum. And we're looking at the gradient on the right-hand side. Now, for the second derivative test, what you would do is, okay, we have our first derivative, which was f prime of x equals 6x minus 6x squared. So for the second derivative test, what you would do is take the derivative, so that's going to be 6 minus 12x. All right, and what we're looking at is our critical values of x equals 0 and x equals 1. So when you plug in 0, we want f prime of 0. You plug in 0 into this. And when you plug that in, you get 6, which is greater than 0. So since it's greater than 0, we have f of 0, which we already know equals 1, is going to be a local minimum. All right. Now for f double prime of 0, of 1, sorry, my critical value is 1. You plug 1 into this here and you get negative 6. Well, that's negative. So since it's negative, we have f of 1, which equals 2, is a local maximum. So both of these methods are easy. So either method is fine. You just have to know the rules. This one, all you do is take the second derivative and plug in your x critical values and see if it's positive or negative. And that's it. Thank you. Have a nice day. Bye-bye.